For decades, we were taught that the extinction of the dinosaurs was the most violent moment in Earth's history. A single impact, a sudden end, a closed chapter. But the planet remembers something else. Hidden beneath layers of ice, buried inside ocean sediments, and etched into the scars of the land itself, there is evidence of a catastrophe so abrupt, so overwhelming, that it reshaped the world in a matter of years, not millennia. A disaster that didn't just wipe out species, but shattered climates, erased cultures, and nearly ended the human story before it truly began. And most people have never heard of it. Because this event doesn't fit neatly into textbooks. It doesn't sit comfortably in timelines. And it raises a disturbing possibility that Earth has already survived something worse than the dinosaurs. And we almost forgot it ever happened. 12,000 years ago, the planet was emerging from the last ice age. Massive glaciers covered entire continents. Sea levels were hundreds of feet lower than today. Human beings lived in scattered groups, adapting slowly to a harsh but predictable world. Then, suddenly, everything changed. Temperatures plunged, ice returned, wildfires swept across continents, floods drowned coastlines overnight. Entire ecosystems collapsed in what should have been an age of recovery, not destruction. The climate didn't shift gradually. It snapped. This moment is known as the Younger Dryas, a period of abrupt global cooling that arrived without warning and rewrote the course of life on Earth. And for a long time, science struggled to explain how such a drastic reversal could happen so fast. But in recent years, new evidence has begun to surface. Microscopic spheres of melted metal, nanodiamonds formed under extreme pressure, layers of platinum embedded in ice cores, glass fused by unimaginable heat. These are not the fingerprints of slow climate change. They are the signatures of impact. Something struck Earth, or exploded above it, or shattered into fragments that rained fire across the planet. Whatever it was, it unleashed a chain reaction that rivaled, and in some ways surpassed, the event that ended the age of dinosaurs. And yet, unlike the dinosaur extinction, this catastrophe didn't leave behind a clean break in the fossil record. Instead, it left confusion, gaps, anomalies, myths, because humans were there to witness it. Across the world, ancient cultures tell remarkably similar stories. Stories of a sky that burned, of fire falling from above, of floods that swallowed the land, of a world destroyed and remade. These myths were never just stories. They were memories. Memories passed down by survivors who watched their world collapse and tried to preserve what they had learned. Survivors who encoded warnings into stone, symbols, and alignments that would outlast written language. They built monuments aligned with the stars. They marked the passage of time with obsessive precision. They tracked celestial cycles as if waiting for something to return. And slowly, as centuries passed, their warnings faded into legend. Modern civilization rose, science advanced, technology flourished. And we told ourselves that humanity had always lived in a stable world, that catastrophes belonged to the distant past. But the evidence says otherwise. Beneath the ice of Greenland, scientists have found sudden spikes in debris that shouldn't exist. Beneath the oceans, sediment layers reveal rapid flooding events that reshaped coastlines in a single generation. Across continents, archaeological sites show abrupt abandonment, burned layers, and cultural collapse synchronized across vast distances. These patterns don't point to coincidence. They point to a reset, a moment when Earth reminded life how fragile balance truly is. And here's the most unsettling part. The cosmic debris linked to this catastrophe may not be gone. Fragments of the same ancient objects still move through our solar neighborhood today. We track some of them. Others remain invisible until they are dangerously close. The cycle that once shattered the prehistoric world may still be incomplete. Which means this story is not just about the past. It's about now. Because if Earth has already survived something worse than the dinosaurs, then the question we should be asking is not what happened back then, but whether we are prepared if it happens again. This is not a story of speculation. It is a story of evidence, memory, and silence. A story hidden in ice cores and ancient stone. A story written in fire, flood, and survival. A story humanity almost forgot, until now. The first signs of a forgotten catastrophe. Long before the idea of a global catastrophe entered mainstream science, the first clues appeared quietly, almost accidentally. They didn't arrive as headlines or bold theories. They emerged as inconsistencies, details that didn't belong, measurements that refused to line up, layers in the earth that told a story no one was prepared to hear. In the mid-20th century, geologists drilling deep into polar ice expected to find a smooth, gradual record of climate change. Ice ages, they believed, advanced and retreated slowly, over tens of thousands of years. The Earth, in this view, was stable, predictable, and patient. But when scientists examined ice cores from Greenland, something unsettling appeared. Around 12,000 years ago, the chemical signatures shifted abruptly. Temperatures dropped sharply, not over centuries, but within a human lifetime. This sudden reversal became known as the Younger Dryas, and from the very beginning, it didn't make sense. The planet had been warming steadily as the last ice age ended. Glaciers were retreating, ecosystems were recovering. Everything pointed toward stability. Then, without warning, the climate slammed back into near-glacial conditions. In some regions, average temperatures dropped by more than 10 degrees Celsius in a matter of years. Forests died. Ice advanced again. Entire food chains collapsed. At first, researchers searched for familiar explanations. Changes in ocean currents, meltwater disrupting the North Atlantic circulation, internal climate variability. These ideas could explain gradual shifts, but not a global shock this fast, this widespread, and this violent. As more data emerged, the mystery deepened. Across North America and Europe, archaeologists began noticing the same strange pattern in ancient sites. Settlements were abruptly abandoned. Cultural traditions ended suddenly. In many locations, a thin, dark layer separated older human occupation from what came after. This layer, sometimes called the black mat, contained charcoal, soot, and burned organic material, as if massive fires had swept across the land. These were not isolated wildfires. The burn marks appeared across continents, synchronized in time. At the same depth, researchers found something even more disturbing. Tiny spherical particles, microspherules formed when metal melts at extreme temperatures and then cools rapidly in the air. Alongside them were nanodiamonds, crystals that only form under pressures far beyond volcanic eruptions or normal geological processes. These materials are rare on Earth's surface, but they are common in cosmic impacts. Still, the idea that an extraterrestrial event could have triggered the Younger Dryas was controversial. The extinction of the dinosaurs had already been attributed to an asteroid, and many scientists were reluctant to invoke the same explanation again, especially for an event so close to the rise of human civilization. But the evidence kept accumulating. In Greenland ice cores, scientists detected sudden spikes in platinum and iridium, elements associated with meteorites. In lake sediments across multiple continents, the same chemical fingerprints appeared at the same moment in time. The odds of coincidence began to shrink. What made this event different from the dinosaur extinction was not its scale alone, but its complexity. There was no single massive crater, no obvious smoking gun. Instead, the data suggested fragmentation, a large object breaking apart as it entered Earth's atmosphere, detonating in multiple airbursts and impacts across the northern hemisphere. A cosmic shotgun blast, rather than a single bullet. This scenario would explain the firestorms. The sudden cooling, the widespread destruction without a single crater large enough to dominate the landscape. And it would explain why the catastrophe faded into obscurity. Airbursts leave scars, not holes. As scientists re-examined ancient landscapes with modern tools, more anomalies surfaced. Beneath layers of soil and vegetation, radar imaging revealed chaotic debris fields. In some regions, strange oval depressions appeared, too irregular for volcanoes, too scattered for tectonic activity. In others, melted silica suggested temperatures exceeding 2,000 degrees Celsius, far beyond what natural fires could produce. Meanwhile, paleontologists noticed something else. The Younger Dryas coincided with the sudden disappearance of large Ice Age animals: mammoths, mastodons, giant ground sloths, saber-toothed cats. Many species vanished almost simultaneously across vast regions. For decades, the dominant explanation blamed human overhunting. But this theory struggled to explain the speed and global synchronicity of the extinctions. Humans were present, but not everywhere, and not in numbers large enough to wipe out entire ecosystems at once. A rapid environmental collapse made far more sense, and humans, it turned out, barely survived it. Genetic studies suggest that human populations at the end of the Ice Age went through a severe bottleneck. Numbers dropped sharply. Entire groups disappeared. Those who lived adapted to a harsher, more unstable world, one where memory of the catastrophe lingered long after the physical scars began to fade. That memory may be the origin of the flood myths, the fire from the sky legends, the stories of a world destroyed and reborn. Not allegory, but testimony, a way to preserve truth when writing did not yet exist. As the Younger Dryas ended and the climate stabilized once more, humanity began something new. Agriculture appeared. Permanent settlements formed. Monumental architecture emerged. Civilization, as we know it, rose from the ashes of collapse. But the warning embedded in that collapse was never fully understood. Because the catastrophe did not announce itself with certainty, it left clues scattered across disciplines: geology, archaeology, climatology, astronomy. No single field could see the whole picture alone, and for centuries, no one thought to connect them. Only now, with modern instruments and a willingness to question old assumptions, are those first signs aligning into a coherent narrative. A narrative that suggests Earth did not simply stumble into a cold phase 12,000 years ago. It was struck. And what followed was not just a climate anomaly, but the first near-miss extinction of humanity itself. The deeper scientists looked, the clearer the pattern became. And with each new discovery, the same uneasy realization returned. If this catastrophe happened once, it could happen again. And the signs were never hidden. We just didn't know how to read them. Fire from the sky. If the Younger Dryas marked a sudden break in Earth's climate, the true question was no longer when it happened, but how. For years, scientists searched for a mechanism powerful enough to plunge the planet back into near Ice Age conditions almost overnight. Ocean currents alone could not do it. Volcanic eruptions did not match the timing or the scale. Something else had intervened. Something fast, violent, and external. The first serious clues came not from craters, but from the sky. Astronomers studying near-Earth objects noticed something unsettling about one particular family of debris, the Taurid complex. This vast stream of asteroids and comet fragments intersects Earth's orbit every year. It is not a single object, but a dispersed cloud, remnants of a massive comet that broke apart tens of thousands of years ago. Some fragments are small, others are kilometers wide. Many remain dark, difficult to detect, and capable of delivering enormous energy without warning. When researchers traced the orbital history of this debris stream, an uncomfortable alignment appeared. Around 12,000 years ago, Earth would have passed through a far denser region of the Taurid complex, one thick enough to dramatically increase the probability of impacts and airbursts. This was not a single collision, it was a storm. In such a scenario, large fragments would explode in the atmosphere, releasing energy equivalent to thousands of nuclear weapons. Smaller fragments would strike the ground, oceans, and ice sheets. The result would be global firestorms, shockwaves, and the injection of vast amounts of dust and aerosols into the atmosphere. The sky itself would have become a weapon. Evidence for this kind of event does not look like a classic crater. Instead, it appears as widespread destruction, without a central point of impact. This is exactly what researchers began to find. Across North America, Europe, and parts of Asia, geological layers dating to the onset of the Younger Dryas contain shocked quartz, melted glass, and high-temperature minerals formed in milliseconds. These materials tell a story of intense heat delivered from above. In some locations, scientists discovered carbon spherules, tiny balls of carbon formed when organic matter is exposed to extreme temperatures without enough oxygen to fully burn. These spherules appear in concentrations far higher than normal wildfires can produce. They are signatures of continental-scale ignition. The landscape itself bears the scars. Satellite imagery and aerial surveys have revealed thousands of elliptical depressions across the northern hemisphere, particularly in regions once covered by ice. These formations are consistent with oblique impacts and airbursts, where objects strike at shallow angles or detonate before reaching the ground. Over time, erosion softened their edges, masking their origin. But the pattern remains. Then there is the ice. When a cosmic fragment strikes or explodes over an ice sheet, the consequences are catastrophic. Ice vaporizes instantly, releasing enormous volumes of water into the atmosphere. Meltwater surges across the land. Sea levels rise in pulses, not gradually. And the sudden influx of fresh water disrupts ocean circulation on a planetary scale. This is exactly what the geological record shows. At the beginning of the Younger Dryas, meltwater floods swept across North America. Massive glacial lakes burst their boundaries, carving scars still visible today. Similar flooding events occurred in Europe and Asia, suggesting a synchronized trigger rather than isolated failures. Fire, flood, and darkness followed one another in rapid succession. As debris filled the atmosphere, sunlight was blocked. Temperatures dropped sharply. Growing seasons collapsed. Plants died. Herbivores starved. Predators followed. The world entered a sudden and brutal winter, not from ice alone, but from the aftermath of impact. This sequence mirrors what scientists understand about nuclear winter scenarios. But this was no human-made disaster. It was cosmic, and humanity was caught in the middle of it. At the time, human societies were small, mobile, and deeply tied to their environments. A collapse of ecosystems meant immediate danger. Food sources vanished. Migration routes became deadly. Survival depended on adaptation, memory, and luck. Some groups did not survive at all. Archaeological layers from this period show abrupt cultural breaks. Tool styles disappear. Settlement patterns shift overnight. In some regions, there is a silence that lasts centuries before humans return. Yet in the midst of devastation, something remarkable happened. People remembered. They remembered the sky burning. They remembered fire falling from above. They remembered the cold that followed. These memories did not remain as data or measurements. They became stories, passed from generation to generation as warnings disguised as myth. In Native American traditions, there are tales of a time when the world burned and froze, when animals died and people fled underground. In ancient Near Eastern myths, gods hurl fire from the heavens, destroying an earlier age. In Asia, legends speak of a sun that behaved strangely, scorching the land before disappearing. Different cultures, same event. These stories were not invented to explain the world. They were inherited from those who watched it end. Modern science once dismissed such accounts as coincidence or imagination. But when aligned with geological and astronomical evidence, they take on a different meaning. They become corroboration. The Younger Dryas was not simply a climate anomaly. It was a planetary trauma triggered by forces beyond Earth's control. And here is the part that unsettles scientists the most. The torrid complex still exists. Earth continues to pass through it every year. Most of the time, the fragments are small. They burn harmlessly in the atmosphere. But the larger objects remain largely uncharted, dark, silent, difficult to track. The storm that struck 12,000 years ago may not be over. It may simply be in remission. The fire from the sky did not belong to the past alone. It was a preview. And as humanity looks back at the scars it left behind, another realization begins to form, one that ancient survivors may have understood all too well. The danger did not end when the climate recovered. It only went quiet, when the ice melted overnight. If fire from the sky marked the opening act of the catastrophe, water delivered its most devastating consequences. The Younger Dryas was not only a story of impact and flame, it was a story of ice collapsing faster than the planet had ever experienced, and of oceans rising in violent pulses that rewrote the map of the world. For most of the last ice age, enormous glaciers locked away vast quantities of water. Sea levels were dramatically lower than today, exposing coastlines, land bridges, and entire regions that no longer exist. Humans migrated across these exposed lands, built camps near ancient shores, and adapted to a world whose geography felt permanent. Then the ice began to fail. Geological records show that around the onset of the Younger Dryas, melting did not occur gradually. Instead, it happened in surges, what scientists now call meltwater pulses. In a matter of years, perhaps even months, unimaginable volumes of fresh water were released into the oceans. This was not a gentle thaw. It was a collapse. In North America, the Laurentide ice sheet began to fracture. Beneath it lay immense glacial lakes, held in place by ice dams that had formed over thousands of years. One of the largest, Lake Agassiz, covered an area larger than all of today's Great Lakes combined. When its ice barriers failed, the result was catastrophic. Trillions of tons of fresh water surged into the North Atlantic. This sudden influx disrupted the planet's climate engine. Ocean currents that distribute heat around the globe weakened or shut down entirely. Warm water stopped flowing north. Cold Arctic air spread southward. Within a shockingly short span of time, regions that had been warming plunged back into near-glacial conditions. The climate system did not adapt. It snapped. At the same time, coastlines across the world began to disappear. Sea level rise during the Younger Dryas was not smooth. It came in jumps, meters at a time. Low-lying plains were swallowed. River valleys became seas. Entire ecosystems vanished beneath salt water. What had once been habitable land became memory. One of the most haunting examples is Doggerland. This vast landmass once connected Britain to mainland Europe. It was home to forests, rivers, animals, and human communities. Archaeological finds, dredged from the North Sea, tools, bones, even human remains, confirm that people lived there for thousands of years. Then, the sea came. As ice melted and water surged, Doggerland was slowly flooded, shrinking year by year. But evidence suggests its final destruction may have been sudden, a massive inundation that erased what remained in a geological instant. To those who lived there, it would have felt like the world ending beneath their feet. Similar stories appear across the globe. In Southeast Asia, the Sunda Shelf, a vast extension of the Asian continent, was submerged, isolating islands like Indonesia and reshaping migration routes forever. In the Americas, coastal plains disappeared, erasing early human settlements that now lie hidden beneath the ocean floor. In the Mediterranean, rising seas transformed inland basins into the waters we know today. The Younger Dryas did not just change climate, it destroyed geography. And with geography went memory. When coastlines vanish, so do the traces of those who lived along them. Camps, villages, burial sites, everything is lost beneath layers of sediment and salt water. This is one of the reasons the archaeological record appears so thin for this period. Not because humans were absent, but because their world no longer exists above the surface. For survivors, the trauma would have been incomprehensible. Imagine watching the land your ancestors walked for generations disappear beneath the sea. Imagine fleeing inland as water consumes forests and plains. Imagine the sky darkened by debris, the climate collapsing into cold, and the familiar rhythms of the world breaking apart. This is the origin of flood myths, not poetic exaggerations, but collective memory shaped into story. From Mesopotamia to India, from the Americas to Australia, cultures speak of a great flood that destroyed an earlier world. A flood sent not as punishment, but as consequence. A flood that arrived suddenly and spared only a few. The consistency of these stories is not accidental. They describe a real experience shared across continents, an experience born from rising seas and collapsing ice. And there is more. Marine sediment cores reveal abrupt changes in ocean chemistry at the same time. Oxygen levels dropped. Marine life suffered massive die-offs. Coral systems collapsed. The oceans themselves entered a state of shock, struggling to recover from the sudden freshwater injection. This chain reaction extended far beyond coastlines. As seas rose and currents faltered, weather patterns shifted violently. Monsoons weakened or intensified unpredictably. Storms grew more frequent and severe. Drought struck some regions while others drowned. The planet entered a phase of instability that lasted centuries. Human societies that had begun to settle and experiment with early forms of agriculture were forced back into survival mode. Stability vanished. Mobility became essential again. And yet, something extraordinary happened after the chaos subsided. When the Younger Dryas finally ended and temperatures rose rapidly once more, humanity did not return to the old ways. Instead, people began to build differently. They marked time differently. They remembered the sky, the ice, and the flood. Monuments appeared. Structures aligned to solstices, equinoxes, and celestial cycles. Sites like Göbekli Tepe emerged, built by people who were supposedly simple hunter-gatherers, yet possessed a profound understanding of time and the heavens. It was as if the catastrophe had taught a lesson that could not be ignored. Never assume the world is stable. Never forget what the sky can do. Never stop watching. The ice had melted overnight once. The sea had risen without mercy. And those who survived understood something fundamental about existence on Earth. Balance is temporary, and when it breaks fast. The flood was not the end of the catastrophe. It was its echo, spreading the damage, erasing the evidence, and reshaping the planet in ways we are still trying to understand. But beneath the oceans and the ice, beneath the myths and the memories, the scars remain. And they point to a truth that grows harder to ignore. The Earth did not ease into the Younger Dryas, it was forced there. And the forces capable of doing that had not disappeared. The collapse of the Ice Age world. By the time the fires had scorched the land and the seas had risen to erase coastlines, the Ice Age world was already collapsing from the inside. The Younger Dryas was not a single event. It was a cascading failure, a chain reaction in which one shock triggered another, until the systems that sustained life simply stopped functioning. To understand the scale of this collapse, scientists began looking beyond ice cores and impact markers. They turned to ecosystems, to pollen trapped in sediment, to the bones of animals frozen in time. And what they found revealed a biosphere pushed past its limits. Across the northern hemisphere, forests vanished almost simultaneously. In their place appeared tundra and steppe, cold, adapted landscapes spreading rapidly southward. This transformation did not take thousands of years. In some regions, it unfolded in decades. Trees that had survived centuries of gradual climate change died standing, unable to adapt to the sudden cold and shortened growing seasons. With the forests gone, the great Ice Age animals followed. Mammoths, mastodons, woolly rhinoceroses, giant bison, saber-toothed cats. Species that had endured repeated glacial cycles disappeared in a geological instant. Their extinction patterns were too abrupt, too widespread, and too synchronized to be explained by hunting alone. Humans may have played a role, but they were not the executioners of an entire megafaunal world. The environment had turned against them. Frozen carcasses discovered in Siberia tell a chilling story. Some mammoths still had undigested food in their mouths and stomachs, plants that could not have grown in the climate they died in. This suggests rapid freezing, a sudden drop in temperature so extreme that animals were caught mid-movement, mid-meal. These were not slow deaths, they were shocks. The same suddenness appears in human records. Archaeological cultures that had persisted for thousands of years vanish at the Younger Dryas boundary. Tool traditions end. Settlement patterns collapse. In some regions there is a silence that lasts generations. No evidence of human presence at all. Genetic studies confirm what archaeology suggests. Human populations went through a severe bottleneck during this period. Numbers dropped dramatically. Diversity shrank. Survival became a matter of chance, location, and adaptability. Those who lived were those who moved. Nomadic groups retreated to refuges, coastal highlands, river valleys, caves, and regions less affected by the worst climate swings. In these pockets, knowledge survived, skills survived, memory survived, and memory mattered. Because the collapse of the Ice Age world was not just environmental, it was psychological. Imagine living through a time when the rules of nature no longer applied, when seasons failed, when familiar animals vanished, when the land itself betrayed expectations passed down through generations. Trust in the stability of the world would have shattered. This is when myth begins, not as fantasy, but as a survival mechanism. Stories allowed people to encode experiences too traumatic, too complex, or too vast to describe directly. Fire from the sky became angry gods. Floods became punishments or rebirths. The cold became a curse that followed human arrogance. These narratives were not meant to entertain. They were meant to warn. Across continents, the same themes appear. A previous world destroyed. A handful of survivors. Knowledge preserved through catastrophe. A promise that the disaster could return. The collapse of the Ice Age world also left another legacy, one that science only recently began to recognize. At the end of the Younger Dryas, when temperatures rose again just as abruptly as they had fallen, humanity did something unprecedented. Within a few thousand years, an eye blink in evolutionary terms, agriculture emerged independently in multiple regions. Permanent settlements appeared. Monumental architecture followed. Civilization exploded into existence. This sudden acceleration has long puzzled researchers. Why did humans remain relatively static for tens of thousands of years, then change everything so quickly? One answer lies in trauma. A population that has survived near extinction does not forget the conditions that nearly destroyed it. Stability becomes sacred. Predictability becomes essential. Control over food, water, and time becomes a priority. Agriculture was not simply an innovation. It was a response to fear. Monuments, too, were not just expressions of belief. They were instruments of memory. Stone does not forget. Alignments do not drift. A monument aligned to the sun will continue to mark time long after storytellers are gone. Sites like Göbekli Tepe challenge everything we thought we knew about early humans. Built at the very end of the Younger Dryas, it features massive stone pillars carved with symbols of animals, stars, and abstract forces. It was not a village. It was not a temple in the later sense. It was a message, a record of a world destroyed, and a warning to those who came after. The collapse of the Ice Age world forced humanity to evolve, not slowly, but under pressure. It reshaped culture, belief, and technology. And it did so because the catastrophe was not theoretical. It was lived. This is why the Younger Dryas matters so deeply. It is not just a climate anomaly. It is not just an extinction event. It is a turning point where Earth reminded life of its vulnerability, and where humanity learned, painfully, that survival depends on memory. And yet, even as civilization rose from the ruins of that collapse, the true cause of the catastrophe faded from awareness. The scars softened. The stories blurred. The warning became myth. Until modern science began to uncover the evidence once again. The collapse of the Ice Age world was not an accident. It was the result of forces far beyond human control. And as researchers continued to piece together the clues, One realization grew increasingly difficult to ignore. The event that shattered that world did not exhaust its power. It changed the planet. It changed humanity. But it may not have been the last time Earth would face such a reckoning. The survivors who remembered. When the Ice Age world collapsed, survival was not guaranteed by strength or numbers. It was secured by adaptability, memory, and the ability to learn from catastrophe. Those who endured the Younger Dryas did not simply rebuild. They transformed the way humanity understood the world. In the wake of global destruction, human groups scattered into refuges. Some moved toward higher ground, away from unstable coastlines. Others followed rivers inland, seeking predictable water sources. Caves, valleys, and regions shielded from extreme climate swings became sanctuaries. In these places, fragments of knowledge were preserved, passed quietly from one generation to the next. These survivors did not forget what they had witnessed. They remembered the sky burning. They remembered the cold arriving without warning. They remembered the land flooding, animals disappearing, and seasons failing. But memory alone was not enough. They needed a way to ensure that what they had learned would not be lost again. This is where the nature of human culture changed. Before the Younger Dryas, human societies left behind tools, camps, and art. After it, they began leaving something different. Symbols meant to last. Patterns meant to endure. Structures designed not just for use, but for remembrance. Across the world, the same shift appears. In Anatolia, Göbekli Tepe rose from the earth with pillars weighing tens of tons, arranged in precise circular formations. These were not shelters. They were not fortresses. They were deliberate constructions built by people who understood geometry, alignment, and symbolism far beyond what their technological level should suggest. The carvings are not random. Predators dominate the imagery. Lions, snakes, scorpions, vultures, animals associated with danger, death, and transformation. Many researchers believe these figures represent cosmic forces, constellations, or events witnessed in the sky. Göbekli Tepe was built at the exact moment the Younger Dryas ended. It was not a coincidence. Across Europe, stone circles and alignments began to appear. In the Levant, early astronomical markers were constructed. In Asia, sacred sites were placed at precise geographic locations tied to solar and lunar cycles. In the Americas, ancient earthworks mirrored the movements of the heavens. These structures shared a common purpose: to anchor memory in stone. Stone does not forget fire. Stone does not forget flood. Stone does not forget time. By encoding knowledge into architecture, the survivors created a language that could outlast oral tradition. Even if stories changed, even if names were forgotten, the alignments would remain. The sun would still rise where the builders intended. The solstice would still return. The sky would still be watched, and the warning would persist. This shift also explains the sudden explosion of symbolic thought in the archaeological record. Cave art became more abstract. Symbols replaced literal scenes. Geometry replaced depiction. Human figures became rare, while animals, stars, and shapes dominated. It was as if humanity stopped telling stories about itself and began telling stories about the world. Stories about forces larger than any individual or tribe. This transformation was not driven by curiosity alone. It was driven by trauma. Modern psychology shows that survivors of extreme events often become hyper-focused on prediction, pattern recognition, and control. They scan for signs of danger. They ritualize behavior. They encode memory through repetition. The survivors of the Younger Dryas did the same. On a civilizational scale, they tracked the sky obsessively. They marked time with unprecedented precision. They aligned monuments to cycles they feared might return. And in doing so, they laid the foundation for civilization itself. Agriculture emerged not merely as an innovation, but as insurance. Control over food meant survival if the climate shifted again. Permanent settlements allowed storage, planning, and coordination. Calendars ensured planting aligned with seasons that could no longer be trusted to behave normally. Civilization was built on the memory of collapse. Yet, over generations, the direct experience of catastrophe faded. The survivors' grandchildren inherited rituals without context. Their great-grandchildren inherited monuments without explanation. Over time, meaning transformed into myth. The fire from the sky became gods. The flood became divine punishment. The cold became a curse or a test. What began as memory hardened into belief. But even belief preserved fragments of truth. Myths across the world speak of teachers who arrived after the destruction. Figures who brought knowledge, agriculture, and order to a shattered world. Quetzalcoatl, Viracocha, Oannes, Thoth. Different names, same archetype. These figures were not gods in the modern sense. They were cultural memories of survivors who carried knowledge across generations, keepers of the warning, and they understood something that later civilizations forgot. The world is not stable by default. Catastrophe is not an anomaly. It is a recurring feature of Earth's history. As centuries passed and stability returned, humanity grew confident. Empires rose. Writing replaced memory. Stone monuments became symbols of power rather than warning. The original message faded, but it never disappeared. Because beneath the rituals, beneath the myths, beneath the monuments, the evidence remained, waiting for a time when humanity would once again have the tools to read it. The survivors of the Younger Dryas did not save the world, they saved the lesson. And that lesson, carved into stone and carried through time, was simple and terrifying. The sky can change everything, and it will, again. The question they left behind was not whether catastrophe would return, but whether the next civilization would remember in time. The silence in the record. If the catastrophe of the Younger Dryas reshaped the planet and the survivors carried its memory forward, there remains one unsettling question that refuses to go away. Why is so much of this story missing? When modern researchers began assembling the evidence, they expected resistance from nature. Erosion, tectonic shifts, rising seas, these erase history efficiently. But what they encountered was something different. A silence, a gap so precise, so persistent, that it felt less like loss and more like absence. The archaeological record around the end of the Ice Age does not taper off. It breaks. Entire cultural sequences vanish. Long-established traditions stop abruptly. In many regions, there is no gradual transition from one way of life to another, only an ending, followed by centuries of emptiness. Sites that should show continuity instead show abandonment. Layers that should contain artifacts contain nothing at all. This is not how slow decline looks. This is how interruption looks. For decades, this absence was explained away as coincidence, preservation bias, lack of excavation, bad luck. But as more sites were studied across continents, the same pattern appeared again and again. A sharp cutoff, a dark layer, a pause in human presence. In North America, the Clovis culture, once thought to be the first widespread human tradition on the continent, disappears almost overnight at the Younger Dryas boundary. Its distinctive tools vanish from the record. For years, no clear successor appears. It is as if an entire population stepped out of history. In Europe, late Paleolithic cultures fracture and retreat. In parts of Asia, settlement density collapses. In the Near East, early experiments with semi-permanent living are abandoned, only to re-emerge later in a radically different form. What caused this silence? The simplest answer is mortality. The most uncomfortable answer is survival through disappearance. When catastrophe strikes at a planetary scale, survival often requires withdrawal into places that leave little trace. Caves, forest interiors, highlands, temporary shelters built to be abandoned, ways of living designed to leave no footprint. If humans survived the Younger Dryas by becoming invisible, the archaeological silence makes sense. But there is another layer to the silence, one that doesn't come from nature alone. As modern science began revisiting the Younger Dryas hypothesis, particularly the idea of a cosmic impact, the response was not uniform curiosity. It was resistance. Papers were rejected. Funding was denied. Careers were quietly damaged. The subject became controversial not because the evidence was weak, but because the implications were too large. A global catastrophe, only 12,000 years ago, challenges the foundation of how we understand stability, progress, and safety. It suggests that civilization does not rise in a protected bubble. It suggests that history is not a steady climb, but a series of resets. And it suggests that what we call normal is temporary. Institutions are built on continuity. Catastrophe undermines that narrative. This may explain why certain questions remained unasked for so long, why flood myths were dismissed as fantasy, why ancient warnings were interpreted as symbolism rather than memory, why geological anomalies were treated as local curiosities instead of global signals. Silence, in this sense, is not just absence of data, it is avoidance. Yet the Earth does not avoid remembering. Ice cores preserve abrupt chemical shifts. Sediments record sudden flooding. Magnetic signatures reveal disturbances in the planet's field. These are not stories. They are measurements, and they speak clearly. They say the world changed fast. They say life barely adapted. They say something extraordinary happened. The silence in the human record may also reflect something more psychological. Trauma does not always produce stories. Sometimes it produces erasure. Survivors of extreme events often avoid retelling them directly. The pain is too close. The memory too raw. Instead, experience is transformed, encoded into ritual, symbol, and indirect language. Over generations, the original context dissolves, leaving behind fragments that no longer point clearly to their source. This is how warning becomes myth. This is how memory becomes religion. This is how history forgets itself, and yet the silence is not complete. In places where writing later emerged, strange references appear. Mentions of earlier ages destroyed, of kings who ruled before time, of gods who rebuilt the world after fire and flood. These accounts sit uncomfortably beside more conventional histories, often dismissed as allegory or exaggeration. But when placed next to geological data, they align too closely to ignore. The silence, then, is not empty. It is layered. It exists in the gaps between disciplines, in the reluctance to connect evidence across fields, in the discomfort of confronting a past that does not feel safely distant. Because if the Younger Dryas catastrophe was real, if Earth truly experienced a near reset while humans were present, then the story is not over. It becomes a precedent. And precedents are dangerous because they imply recurrence. The survivors may have chosen silence to protect themselves, to move on, to rebuild without constantly reliving the end of the world. But they also left markers, subtle, persistent reminders that the danger came from above, not from within the Earth. Modern science, armed with satellites and sensors, is finally beginning to hear what the silence contains. And what it contains is not reassurance. It is a warning that was never meant to be loud, only durable, a warning written into the planet itself. And as we listen more closely, one realization becomes unavoidable. The greatest threat to understanding the past was never lack of evidence. It was our refusal to imagine that the Earth could change so completely, so suddenly, and do it again. The pattern that refuses to disappear. Once the silence in the record is acknowledged, a deeper question emerges, one that transforms scattered anomalies into something far more disturbing. What if the Younger Dryas was not an isolated accident, but part of a repeating pattern written into Earth's history? When scientists expanded their scope beyond a single event, they began to notice a rhythm. Extinctions, abrupt climate shifts, sudden rises and collapses, each separated by thousands, sometimes millions of years, but sharing the same fingerprints: fire, flood, darkness, recovery. The Chicxulub impact ended the age of dinosaurs 66 million years ago. Volcanic winters reshaped life long before that. Ice ages advanced and retreated with startling irregularity, and threaded through all of it are signs of cosmic disturbance: asteroids, comets, debris streams crossing Earth's path like invisible minefields. The Younger Dryas fits this pattern too well to ignore. Astronomers now know that Earth's orbit periodically intersects regions of space dense with debris. The Taurid complex is only one example. There are others, ancient comet remnants stretched into elongated trails that our planet drifts through on predictable timescales. Most years, nothing happens, allowing us to forget how exposed we really are. But occasionally, Earth passes through a denser cluster, and the consequences are immediate. This realization reframes ancient memory, the obsession with cycles, the fixation on recurring ages, the belief that worlds are destroyed and reborn. These ideas appear in cultures separated by oceans and millennia: the Hindu Yugas, the Mayan suns, the Norse Ragnarok, the Platonic Great Year. Different languages describing the same intuition, that time does not move in a straight line, but in loops. Ancient people were not predicting the future. They were recognizing a pattern, and they encoded it everywhere. Stone circles aligned to long-term solar and lunar cycles. Calendars that track not just seasons, but vast cosmic periods. Myths warning of a return, of fire from the sky, of floods that come again when the balance is broken. Modern science for a long time dismissed this worldview as superstition. Linear progress felt safer. But the data is now forcing a reconsideration. Ice cores reveal multiple abrupt climate reversals, not just one. Sediment layers show repeated flooding events that cannot be explained by slow change. Genetic bottlenecks appear again and again in the human story, suggesting repeated brushes with extinction. The pattern is not perfect. It is not predictable to the year or century, but it is consistent enough to challenge the idea that the Younger Dryas was a fluke. And then there is the most unsettling detail of all. The cosmic mechanisms that likely triggered the Younger Dryas have not gone away. Near-Earth objects continue to be discovered, some only days before they pass close to the planet. Many are dark, absorbing light rather than reflecting it, making them nearly invisible until it is too late. Others are part of long-period debris streams whose full extent we do not yet understand. Technology has improved our vision. It has not eliminated uncertainty. Ancient survivors lived under the same sky we do. They had no telescopes, no satellites, no early warning systems. Yet they watched the heavens with an intensity that borders on obsession, because for them, the sky was not abstract. It had already betrayed them once. This is why so many ancient structures emphasize observation: sight lines, horizons, rising points, setting points. They are instruments, not just monuments. Tools built to watch a threat that moves slowly but strikes fast. And here lies the uncomfortable parallel. Modern civilization depends on stability more than any before it. Global supply chains, dense populations, interconnected systems that assume predictability. A sudden global disruption, firestorms, rapid cooling, flooding, would ripple through society faster than any ancient collapse. In some ways, we are more vulnerable than the people who survived the Younger Dryas. They could disappear into the landscape. We are bound to infrastructure. They expected the world to change. We assume it will not. The pattern that emerges from Earth's history is not one of safety, but of survival through adaptation. Each time the planet resets, life continues, but only after enormous loss. Each time, memory fades and confidence returns. And each time, the warning must be rediscovered all over again. The Younger Dryas was one chapter in that cycle. It was not the beginning. It was not the end. It was a reminder that Earth does not owe stability to anyone. A reminder that catastrophe is not an exception. It is a feature of deep time. A reminder that intelligence survives only if it learns to pay attention. As the evidence aligns, geological, astronomical, archaeological, the pattern becomes impossible to ignore. The same forces that shape the past still shape the present. The difference now is that we can see them coming. Or at least, we think we can. And that belief, comforting as it is, may be the most dangerous assumption of all. Because if the past teaches us anything, it is this: the Earth does not announce its resets in advance. It leaves warnings behind, and whether those warnings are enough depends on whether this time we choose to listen. When the past becomes a warning. As the pieces finally come together, one truth stands out with unsettling clarity. The Younger Dryas was not just a catastrophe buried in prehistory. It was a message written into the earth itself, and like all messages, its meaning depends on whether the receiver chooses to understand it. For thousands of years, humanity lived with an unspoken assumption that the planet was fundamentally stable, that disasters were local, that extinctions belonged to a distant, finished past. But the deeper we look, the harder that assumption becomes to defend. The Earth has reset before. It reset when fire fell from the sky and ignited continents. It reset when ice melted in violent surges and seas swallowed the land. It reset when ecosystems collapsed and human populations nearly vanished. And after each reset, life continued, but never in the same way. The survivors of the Younger Dryas rebuilt their world with a different awareness. They understood that civilization exists on borrowed time, balanced between order and chaos. That is why they watched the sky. That is why they aligned stone to stars. That is why they encoded memory into monuments meant to outlast words. They were not building for beauty alone. They were building against forgetting. Somewhere along the way, we forgot anyway. Modern society replaced memory with data, myth with measurement, warning with probability. We convinced ourselves that risk could be calculated, controlled, and neutralized. That technology had placed a buffer between us and the forces that once shaped the planet. But technology does not change physics. It only helps us notice it faster. The same debris streams still cross Earth's orbit. The same cosmic forces still move silently through space. The same planetary systems still respond violently to sudden disruption. We track many threats, but not all. We understand much, but not enough to guarantee safety. And unlike our ancestors, we have built a civilization that depends entirely on continuity. Food systems that require perfect timing. Power grids that assume stability. Cities that cannot easily move or disappear. A global disruption on the scale of the Younger Dryas would not just challenge humanity, it would test it. This is why the past matters. Not as curiosity, not as entertainment, but as instruction. The Younger Dryas shows us what happens when warning signs are missed, when change comes faster than adaptation, and when memory fades faster than danger. It shows us that intelligence is not measured by what a civilization builds, but by what it remembers. And perhaps that is the final lesson hidden beneath ice cores, sediment layers, and ancient stone. The greatest threat humanity has ever faced was not ignorance. It was forgetting that the Earth can change suddenly. The dinosaurs never knew what hit them. Humans did, and survived. That difference matters, because survival did not come from strength or dominance, but from awareness. From the ability to recognize patterns, to remember catastrophe, and to pass that knowledge forward in whatever form would last the longest. Stone. Story. Sky. Today we have access to more information than any civilization before us. We can see the scars of the past in unprecedented detail. We can connect evidence across disciplines. We can reconstruct events that nearly erased us. What we choose to do with that knowledge is the real question. Will we treat the Younger Dryas as a closed chapter, an anomaly safely locked away in academic debate? Or will we recognize it as what it truly is, a rehearsal the planet has already run once? Because the Earth does not need permission to reset. It never has, and the warning was never subtle. It was written into fire, ice, flood, and stone. Earth survived something worse than the dinosaurs. We almost forgot it. The only question left is whether remembering it now will be enough before the next chapter begins.